9702 October November 2021 paper 1 variant 3 top question number 30 and the topic is diffraction grating. So this is the setup and the formula is n, which is the order of spectra. Lambda wavelength equals to d, which is the separation between the slit separation, and theta is the angle of diffraction. So the formula is n lambda equals d sin theta. So what is the question? A ray of green light is incident normally on the diffraction grating. Several bright spots are produced on a screen on the other side of the grating as shown. This is the side. Which pair of changes could result the bright spot exactly the same angle as previous? So angle is not changing. So let's before going into the options, let's revise something. The number of lines per unit length, which is kept, it's n is equals to 1 over d, where d is the order of d is what, the separation, right? So we have this in our theory. If we see the visible lights from violet to red, so violet has the highest frequency and the red has the lowest frequency. Violet has the lowest wavelength and the red is the highest wavelength. Okay, and it says a green light. So the green light is having wavelength uh, lesser than the red light. So if we, which pair of changes they need to know with the having the same angle of diffraction, which changes we need to change something could result the bright spot and with the same angle as previous. So this is, angle should not be the change, bright spot we got, and but we need to change something. So n lambda equals d sine theta. Lambda is equals to sine theta over n. So if n is reciprocal of slit separation, so that means lambda is also reciprocal to inversely proportional to capital N. And N is what? Number of lines per unit length. So because why we did that? Because it is given two thing, distance of the grating and the screen, and the increasing the number of lines per unit length. So N is the number of lines per unit length. So angle is sine theta inverse and lambda d. So this is the variation. So we d means the separation, we replace with n. So if d and n are reciprocal, so n is the reciprocal of 1 over d. So instead of 1 over d, we write n. So this is the final derivation. Theta equals sine inverse n lambda capital N, where n capital N is the number of feed lines per unit length. So we don't need to change the angle. Angle should be the same. So if n increases, lambda should decreases, and if lambda increases, n should be decreases in order to get the same angle. Okay. So this we need to understand. Now, use option A. Use blue light and increases the distance between the grating and the screen. Grating and the screen means they are increasing the distance between this grating and this screen, which will gives no effect. So I will straight away ignore the option A and the option C, where it has the distance between the grating and the screen. So the remaining is option B and option D. Option D says use red light and increase the number of lines. If we replace green light with red, that means we are increasing the wavelength. If the wavelength increasing, then n should be decreased. The n should be decreased. But it says number of n increase the number of lines per unit length. So both are increasing. So definitely angle will increase. And the options and the question says the same angle. So option D is also incorrect. Use blue light. Blue light has an wavelength lesser than the green light. So that means lambda is decreasing. If lambda is decreasing and will increase, then the angle will be remain the same. So it says the number of lines per unit length of the grating increase. So this will make no difference because if lambda is decreasing and is increasing. So option B is the right answer. And this question having a solid knowledge of diffraction grating, right? So this was a difficult question but, faced by many of the students, right? And most of the student marked the wrong answer.